This is our torsional experiment.
Hello, I am Najiha. For this mini project, we decide to use table sharpener for our torsional experiment. Table sharpener were used for round, triangular and hexagon pencil with standard size 8 mm diameter. The purpose of a torsion test is to determine the behavior a material exhibits when twist or under torsional force. So, as a result of apply movement that cause shear stress about the axis. In this case, we will use material alloy. Torsion test twist a material or test component to a specific degree with a specific force or until the material fail. The twisting force of a torsion test is applied to the test sample by ensuring one end so that it cannot move or rotate and applying a movement to the other end so that the sample is rotated about the axis.
Hi, my name is Nurul Shahida Akila binti Zanurin. I will talk about discussion, so let's go. Product table sharpener was selected according to tensional system of the product. We already attached the table sharpener with dimension that we use. The sample calculation for the polar moment of initial displacement is provided above in calculation section. In this experiment, we decide to use pencil with different materials such as plastic, wood, and paper. While performing the experiment, human error calibrating the equipment, applying load, which is the pencil, and taking reading can cause alter the result. The limitation of the machine can also cause error in the reading. It is impossible to predict the point where failure will occur as a result of tensile loading. Failure mostly occur at the point which has any internal defect or crack. If not, the point with higher stress concentration will be the point of failure.
Hi, I am Nazrin. So I'm gonna start with explain about the calculation part. First thing first, we need to calculate the force acting on x direction and y direction. So as the force acting on y direction only, so the force at x is 0, while the force acting on y is 10 Newton. And the moment area method that we get is 12.4 Newton. Next, we're gonna calculate the polar moment, which is J equal to pi over 2 times by the radius to the power of 4. So we have the radius at 0.005 meter. So we get the answer is 9.817 exponent negative 10. Next, we're gonna calculate the allowable torque, which is the moment times by the radius and divide by the polar moment, which is J just now. So we get the allowable torque about 63.16 megapascal.
My name is Rahman bin Sumadi and I would like to continue the calculation part. To find the internal torque, shear stress 12.4 Newton plus width, length times force 0.62 meter times 10 Newton. Then we get the internal torque is 18.6 Newton. After that, we can find the torque maximum, which is equal to internal torque times C outer radius 0.005 over the polar moment. After that, we get the torque maximum 113.68 megapascal. Okay, after that, we can find the angle of twist, which is equal to shear stress times length 0.62 over the polar moment of inertia times modulus of rigidity. After that, we get the 0.78313 radian. We have to convert it to degree, then we get 44.87 degree. Lastly, we can find factor of safety, which is equal to torque allowed over torque maximum. Using the data that we calculate, then we get the factor of safety is 1.8.